The chemical rocket engine. The advent of missiles and satellites. And brought to prominence the use of rocket engine as a propulsion power plant. The use of rocket engine as a propulsion power plant. Chemical rocket engine may be classified as either liquid propellant or solid propellant. Liquid propellant or solid propellant according to the fuel used. This figure shows a simplified schematic diagram of a liquid propellant rocket. So we can show a liquid propellant rocket here schematically. This figure shows a simplified schematic diagram of a liquid propellant rocket. The oxidizer and fuel are pumped through the injector plate into the combustion chamber. Oxidizer here and fuel tank pumped to the combustion chamber. Where combustion takes place at high pressure. The high pressure, high temperature product of combustion expand as they flow through a nozzle. So at first we can write the oxidizer and the fuel are pumped to the combustion chamber. The high temperature and high pressure gas product of combustion expand through a nozzle as shown also in the picture here, and at a 3-stage and as a result they leave the nozzle with a high velocity. The momentum change associated with the increasing velocity gives rise to the forward thrust on the vehicle. Momentum increase makes a movement to the vehicle. The oxidizer and fuel must be pumped into combustion chamber, and an auxiliary power plant is necessary to drive the pump. So as shown in the previous picture, we have an auxiliary power plant needs to drive the pumps. In a large rocket, this auxiliary power plant must be very reliable and here a relatively high power output, yet it must be light in weight. The oxidizer and fuel tank occupy the largest part of volume of a rocket, and the range and the payload of a rocket are determined largely by the amount of oxidizer and fuel that can be carried. Many different fuels and oxidizers have been considered and tested, and much effort has gone into the development of fuels and oxidizers that will give a higher thrust per unit mass rate of the flow of reactants. Liquid oxygen is frequently used as the oxidizer in liquid propellant rockets, and the liquid hydrogen is frequently used as the fuel. Other applications of the thermodynamics are different. Many municipal landfill operations are now utilizing the heat produced by the decomposition of biomass waste to produce power, and they also capture the methane gas produced by this chemical reaction for use as fuel. Geothermal sources of heat are also being utilized, as are solar and windmill produced electricity. Sources of fuel are being converted from one form to another, more usable or convenient forms, such as the gasification of coal or the conversion of biomass to the liquid fuel. Hydroelectric plants have been in use for many years, as have other applications involving water power. Thermodynamics is also relevant to such processes as the curing of a poured concrete slab, which produces heat, the cooling of electric equipment, various applications in cryogenic, and many other applications. Several of the topics and applications mentioned in this paragraph will be examined in detail in large chapters of this book. This is the end of the chapter 1. The next chapter is about some concept and definition. This chapter is an introductory chapter, and there is no problem solution in this chapter, but there is problem solution and course discussion in next chapters.